Hey guys, this is Mr. H. Hey, I wanted to do a video on how you can use your graphing calculator to to solve linear inequalities. I know that most of you know how to solve equations with the graphing calculator, but I also now I want to show you how we're going to take the next step, and you should be able to look at two lines and basically see which one is greater than, which one is less than, which direction to go. All right, so let's jump into this. Let me go to my iPad. First thing we're going to do is I'm just going to show you a couple examples, and then we're going to do a few delta math questions, and I'm going to show you how these all go together. All right, so if you look at this, you can see that there's two lines. There's a blue line, there's a red line. And basically what I want to know is where are these two lines? Where are these two lines equal, right? And they're equal where that black dot is, and the intersection occurs at 5, 6. So if I said, where is the blue line equal to the red line? You would say when x equals 5, they're equal. Okay, easy. Now, everyone pretty much knows how to use their calculator to do this. But now I want to go to the next level. In this question, I'm asking, where is the blue line above the red line? Is it to the right of the intersection, or is it to the left of the intersection? Because that's what this question right here is asking. It's saying, where is the blue line always bigger or higher than the red line? Well, if you look here, this is where they're equal. So if you go to the right of that, you can see that the blue line is always above the red line. So anything to the right or greater than 5, you're going to have the blue line above the red line. So that's what you would say. When x is greater than 5, the blue line is always on top of the red line, period. Now, conversely, if I were to say, where is the blue line less than the red line, it would be going the opposite direction. So here's where they're equal. Here's where the blue and red line are equal. But when we go to the left, even the slightest bit left of 5, the blue line is now below the red line. So you would say, well, when x is less than 5, the blue line is below the red line. So when you see blue lines and you see less than, you just got to go find out which direction do you need to go. Once you see the intersection, because that's where they're equal, then everything else it's going to be unequal, and you need to figure out which one is greater, which one's less. Okay, let's look at another example. All right, now, same thing. We got two lines here, and this question is saying, where is the blue line equal to the red line? Well, I have the intersection. It occurs at a -1, 4. We only want the x value, so I'm just going to say when x equals a -1, those two lines are equal. Next, this one, slightly different. It's saying, where is the blue line lower than the red line? Always. Where is the blue line always lower than the red line? Well, they're equal right here. But if you go to the left of this, you'll see that the blue line is below the red line. You can see that. So that's where, so it starts here. It starts at a -1. And if you go to the left, if you go in the left direction, anything less than a -1, the blue line is going to be lower than the red line, which is what it's asking. Now, boom, done. Let me put a question mark in here. Forgot to. And we got one more. Same thing. Question mark. Where is the blue line always going to be above the red line? Again, we can see where they're equal. They're equal when x equals a -1. But when we go greater or to the right, you can see that the blue line is on top of the red line. The blue line is literally on top of the red line. And when I say on top, I mean it's higher. Like if I draw a straight vertical line, you can see that this value is above this. 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 So the blue line is on top of the red line, and it starts at a -1 and it goes to the right. So anything greater than a -1, the blue line is going to be greater than the red line. Or another way of saying that is the blue line is going to be on top of the red line. All right, now let's go look at a couple of questions. I'm going to start with one of these. And I'm going to use a calculator because I want you to see. Now, you guys are looking at this inequality, but what I want you to start to see is that if you graph these, this is going to be the blue line, this is going to be the red line. And what it's asking is, where is the blue line always greater than the red line? That's what we need to find. So the very first thing we need to do is find the intersection, and then we need to look at the graph and see which direction we need to go. Now, I'm going to graph this because I want you to see what I'm saying. It's always going to be a blue line and a red line. So let's do it. So let's go here. All right, and remember, always put the left-hand side into F1. So this is going to be a negative 66 plus 6x. And let's see what it looks like. All right, you can't really see it, so I'm going to zoom out just a little bit. Menu 44. So I press enter, and now you can see the line. It's right here. We got a blue line. Now we're going to do tab, and we're going to put in a negative 42. And negative 42, boom. You don't see it, so let's zoom out. Menu 44, and we're going to put it in the center. Going to zoom out a little more. All right, there we go. We got it. Now, let's take a look at this. I'm going to make this larger so we can see this on the screen. I need y'all to see this. All right, so now, first thing I'm going to do is I'm going to find the intersection because that's where I need to know. That's always my starting point. Menu 64, I come here, boom. In fact, I'm going to drag this up a little bit so you can see it a little better. Okay, so here's my blue, here's my red. Now, what I need to know is where is the blue always going to be greater than the red? And here's the intersection. It starts at 4. Now, if I go to the left, you can see that the red is down here and the blue is up here. If I go over here, I got the red down here and the blue is way up here. So the blue is always on top of the red when I go to the right. So basically, when x is greater than 4, going this direction, the blue is always on top. If you go this direction, you see that the red is above the blue. So let's go back and finish this question. Now, my graph shows you basically the same thing. The only thing that it doesn't show you is I didn't put the y coordinate. And the reason I didn't put the y coordinate is I don't care about the y coordinate. The only thing I care about is the x. So that's all I focus on. I'm just focusing on this. So it's going to be x is greater than 4. That's what this is saying. The blue line is above the red line as soon as you go in this direction. All right. So that's how you do it. Now, I'm not going to graph anymore, but I'm going to go look at a couple more because I want you to see this. Here's another one. So this one is saying, where is the blue line less than the red line? Where is the blue line less than the red line? Well, here's the intersection. The intersection is at 1, but if we go to the left, you can see that the red line is above the blue line. Or another way of saying this is the blue line is below the red line, right? So we're going to the left. So you would say x has to be less than 1. And that would be your answer. That's how you do these. Now, I was showing you before, oh, we'll come out here and we'll plug in the number 4,000 and see if we get a true statement. That's doing more than we need to do. If you can look at the graphs, if you can look at the two lines and say, where is the blue line under the red line? You can say, oh, here's the red line and the blue is underneath it. So anything to the left of the intersection is what we want. This is going to be our solution because anything in here will make this true. All right, let's do maybe one more. Let's look at one of these. Not this one. It's already done. I want to do this one. All right, now you look at this and you see all of this stuff. A negative 6f plus 4 times parentheses 4f plus 2 is greater than or equal to 6f plus 9 minus 7f. Now, what I want y'all to start doing is don't focus on that because we're going to use the calculator. What you need to focus on is what the question is asking. They're saying, where is the blue line on top of the red line? Which direction is the blue line on top of the red line? Well, here's the intersection. So here's where they're equal. But if we go to the right, anywhere to the right of this intersection, you can see the blue is on top of the red. The blue is on top of the red. The blue is on top of the red. So that's going to be our answer. So if we were writing this, we would say when F is greater than or equal to, and here's the intersection, it's actually a fraction. But when F is greater than or equal to 1 over 11, that is going to be your solution. That's what makes this a true inequality. Any number from 1 over 11 above, any number greater than that or equal to that will make this inequality true. And if you want to, you can try it yourself. All right. All right. So let me go back and I want to recap this. I started with this. Now you guys know how to find intersections. That's easy. But now what I need you to do is I need you to be able to look and forget about the inequalities, the actual inequalities. Just look at the left-hand side, and that's going to create a blue line on the calculator. And on the right-hand side, that's going to create a red line on the calculator. And you just need to say, where is the blue line above, because that's greater than, the blue line above the red line? Well, you would have to go to the right of the intersection because that's where it is. The blue line is always up here and the red line is always down here. Okay, I hope this has been helpful because if you understand this, then inequalities and equations are a piece of cake using your graphing calculator. All right, I'm going to stop this and post it.